Hello, test. This will be our first video recording. We'll try to answer some of the homework questions together. For this video, we'll go for homework 3.2. And we'll discuss how to use MATLAB, mainly how to generate a periodic triangular wave. We discussed this in the TA hours, but this is considered a follow-up. So we want to generate the signal in MATLAB, and we want to get more familiar with MATLAB, and we want to know how to calculate the RMS value. So let's start by opening MATLAB. We can go for either new script or new live script. I personally prefer live script because it looks better. Let's check the slides. So we want to generate the signal, and we notice that it's a triangular wave. During the lecture notes, we discussed that there is a ready-made function in MATLAB called sawtooth function that's able to generate this triangular wave, and it takes certain inputs. First, we'll start by defining t. T will be our period. Let's define it as 20. We'll define the amplitude of our signal as 10. We'll define fs as, make it 100 as number of samples, where 1 over fs is the sampling rate. So we want to generate a signal, or we want to generate a time that starts from a negative period, negative t, and that has 1 over fs samples to 2t, 2 times t. Let's plot. Let's create a plot. Call it fs, or let's call it f plot equals. So we mentioned that we'll be using the sawtooth function. Let's say sawtooth. As you can see, MATLAB gives you suggestions as well, so you do not need to memorize anything. So sawtooth, or our triangular periodic function, it's a periodic function, so we need to define it as define its omega as 2 pi times the frequency, which is 1 over t. Times t, which is the input variable, which is the dependent variable, or the time. So this function is just to generate the plot. Let's start plotting this function. So figure plot. So we plot the x-axis versus the y-axis, and we can make the grid on. You can press run here, or you can go for Control-Shift-Enter. I think we need to do a multiplication. So as we can see, the sawtooth function looks like this. Sawtooth function, if you wanted to make it a triangular function, we write half here. This will be our function. Let's say you want to shift this function to the right or left. So as we mentioned, or as we discussed in class, we can create a phase for any periodic function by putting minus or plus. Let's make it plus. A phase phi. And in this example, we can define phi as pi over 4. You can see the function shifts to the right or left. Can try another value. You see the shift is more clear. Right. So once you adjust your function and you are satisfied with how it looks, the next step is to calculate the RMS. So to calculate the RMS, RMS is defined as uh, so RMS of a signal S of f of t is the root mean. How to calculate the mean? The mean is the average over time. So I will integrate the signal over one period and divide it by the length of this period. So I will integrate my signal from negative t over 2 to t over 2. Those values can be anything as long as they represent one period, and our signal is f of t. So this will be our RMS. How can we uh, calculate this in MATLAB? We can leave it here. We'll start by integrating this signal. So let's integrate it and plot it as well to see how it looks like. Or I think we missed something in the RMS. Its root mean squared. So first we square the signal, then we integrate it, then we divide it by the period t. Right. Let's start by squaring the signal. So paste. I want to make sure that everything is correct. Right. And we can just square it this way. So we create another plot called plot2 is equal to the square of the sawtooth function to the power of 2. So to square a signal on every point in MATLAB, you need to put this dot notation just to note that you are squaring every point. And let's plot the second figure. So plot 2. Let's remove the RMS notation. Clear all drawings. So if you are satisfied with this results and you can like manually check at different values, and if you see that the value here is the square of the value in this one, then you can go for the next step. If something is wrong, you have to check again. You have to check that you might be missing. So you mentioned that the RMS is the root mean squared. How to integrate a signal in MATLAB? So to integrate a function, first you have to define it as a function. So let's call it, let's take this f squared and define it as a function. And call this function f, or we can define it here. So f is equals to, f takes a dependent variable t, and you just define the function. So this is how to define a function in MATLAB. Then we mentioned that the root mean squared after after defining the function, you need to integrate this function. There is a ready-made tool in MATLAB for integration. So FINT for integration, or F integral is equals to integral integral, and you just, what do you want to integrate? You want to integrate f. So you can see MATLAB gives you some suggestions. So you integrate it from negative x min to x max. From negative, we mentioned our integration is from negative t over 2 to t over 2. So this is how you integrate a function. after integrating, you will calculate the root mean squared. So I think there is a ready tool there is like a automatic tool in MATLAB to calculate the root mean squared, but we can do it manually. So we can mention that FRMS well the square root of f integral over t. So let's see if we got a value for FRMS. So this is the value of FRMS. What does FRMS mean? So we mentioned that it's the integral of one period. So if you want, you can solve it manually. So you can take one period. Let's notate the signal. Let's make sure that our result is meaningful. So this is our 0. So the integration of a signal is the area under this curve. This is the integration of a signal. So as we were saying, the RMS is the area under the curve divided by uh, t, which is one period. So let's calculate this area. As we can see, the area is like looks like two triangles, and the area of one triangle is its base length is 10 and its height is 1. So half base times height. So half 10, which is 5 times 1, which is 1. So the area of this triangle is 5. So 5 plus 5 is 10. So the total area under our curve in one period is equal to 10. And divided by 20, which is the total length of our period. So 10 divided by 20 is half. So the value of RMS sort of makes sense.